All right, folks, welcome once again. So this is day eight of our 15-day course. So we are about, at the halfway point in this course. And yesterday we started module 5, database services. Today we'll continue that, and I think we'll need the whole session today, right? So because it's a bigger module, so we'll use the next 2 hours to complete the database services module. All right. So yesterday, what we did is we looked at of these 4 services. We looked at RDS, right? We spent a bit of time on RDS, relational database service, and we also started DynamoDB. So we discussed some slides, and we also looked at the AWS console. We saw how to sort of create a table and how to add items and how to do a little bit of scanning and querying of the DynamoDB table as well, right? So today we need to continue this. So I'm going to show you a bit more about DynamoDB, especially how to use the DynamoDB tables within your applications, right? And here, this is a proprietary technology from AWS. So you need to use the AWS API, the AWS SDK, software development kit, for within your applications to be able to sort of talk to the DynamoDB tables. All right, so that's what we need to see. And then once we finish that, we'll look at the other 2 database services, which are Elasticache and Redshift. All right, okay, so let's go back to the management console, right? And let me go back into DynamoDB and recreate, right? So I'm going to recreate the table that we had created yesterday. So let me go ahead and do that. Do the same thing, right? So this is a music table. Remember, let's say this is the world's largest collection, a catalog of songs, right? Let's say that's our use case. The partition key is artist, and the sort key is song title, right? And you'll recognize that this combination of artist and song title is a unique combination, and therefore this is suitable as a primary key. All right. The other thing that you should look at is the capacity. We don't have servers here, right? DynamoDB does not have. We don't create servers. We don't create a cluster of servers, right? We simply specify the read capacity units and the write capacity units, right? So this is how you can specify how much capacity you need, and also when you need to scale, if you want to increase the capacity, you simply have to change the read capacity units or one of these, right? You can change one of these, or you can change both of these as well. Okay, so this is how the capacity is specified and scaled. Okay, no servers in DynamoDB. It's a different kind of service, right? RDS is older technology, right? Technology which we always had, but sort of implemented in the cloud, right? Whereas DynamoDB is different. It's a service or a technology which has been created on the cloud, right? And here you can see the difference. There's no server that we specify. All right. So the table also, it comes up pretty fast, right? And there's no server here, so it's pretty fast. And once this is ready, we'll add our items, right? So items are like the rows in a relational database, right? So we can add items. Let me add the same songs that we had last time, right? So let's say a song by Bob Dylan. This is let's say Tambourine Man, right? And of course, you can also add other fields. Maybe you want to specify the year. Maybe you want to specify the genre, and so on, right? So you can specify whatever attributes you like for an item, and you can save it, right? Now remember, you can also add more items, and when you add the second item, the attributes need not be the same. Okay, so this is called schema-less. NoSQL databases don't have a schema. You have to specify the primary key, right? But the other stuff can be sort of defined on the fly when you're adding the items. All right. Okay, and also, we saw yesterday two sort of read operations. One is scan, and the other is query. Right? Scan is a listing, and query is a very specific query on a particular item. Okay, so this is how you can perform the basic operations, right? But the main thing is when you use DynamoDB, you're not going to be adding items in this way. You will not be scanning or querying the table from the AWS Web Console, right? This is just for test purposes. But what you'll be doing is you'll be using all this in an application, right? So for example, you may have an application which looks like this, right? So let's say Amazon, right? Amazon.com or Flipkart.com. This is e-commerce, right? It's an e-commerce catalog, and here, for example, by the way, this Amazon site, the India site of Amazon, has about 100 million items, right? It has about 100 million catalog items, 100 million products. Okay, so this size you can see is pretty big, right? 100 million is a pretty decent size. I think Amazon.com, the US site, may be even bigger, right? I'm not sure how big that is, but here there are we know from the advertising that they put out that they have 100 million catalog items in this platform, right? Okay, so let's say you want to buy a certain product. Let's say you want to buy a Google Chromebook, let's say, right? So notice first of all that the site performs very fast, right? It works very well, and that's important in the e-commerce domain, because the e-commerce companies know that if the site is not fast, right, then users can get frustrated, and they can go to the competition, or they may want to go to the nearby store, right? So they have to make sure that the application, that the catalog site works really fast. Okay, so when you do a search like this and you get the results, this actually is served by not from a database. It's usually served from a search engine, right? A search engine. So you might have heard of Elastic Search. You might have heard of Solr, right? So these are open source technologies. I think Amazon has its own technology as well, right? So this is different. So when the catalog returns search results, this is from a search technology, from a search engine. All right. Okay. Now, however, when you click on one of these, right? Let's say you click on one of the products here. Let's say this is a Chromebook that you're interested in. So when you click on this link here, right, and you go into the product details, right? So this page is most likely coming from a database like DynamoDB. Okay, this page is the data is retrieved from DynamoDB. Okay, using the primary key. Okay, so you can see on in the URL this bit here, right? The QID probably is the unique identifier of the item, right? Of the product, and using this ID. The application is probably going to DynamoDB and fetching this result. Okay, so this is how this is a real life example of where you will use a NoSQL type of database. Okay, all right. So now you can see here, there's tons of information in this item, right? So there's some description, there's various kinds of pricing, there's additional description, there's you can see here technical information. Then there's also questions. There's also this kind of Q&A, reviews, ratings, and so on. Right. So there's a lot of data, a lot of information about a single product. Right. And all of this you can now imagine. Right. If you have a DynamoDB table for e-commerce, you'll have an item for this Chromebook, and that item will have many attributes, right? So you can have thousands of attributes as well for each item. Okay, but the main thing to note here is that when you need very fast response, and e-commerce companies know that very well, right? If their site is not fast, then they literally lose money, right? Every second that the site is slow or down, they literally lose money. So they ensure that this kind of page is loaded really fast, and also given the size, right? Like I said, there's 100 million records here, right? Given this large size and the need for very fast performance, this is where you'll be using something like DynamoDB. Okay, all right. Now the main point is, how will this application, let's say this is your application, right? How will this application talk to DynamoDB and fetch the result for this product ID, right? So we need to understand how to interact, right? How will our application interact with DynamoDB? All right. Okay. So let me show you some sample code. Okay, I'm going to show you some sample code here. And basically, this is written in Ruby. This is written in Ruby. Ruby is a programming language, right? Some of you may be familiar with it, but even if you're not, it doesn't matter. Okay, it doesn't matter. You can use whatever programming language you like, right? Or your developers like. If you're not a developer in your team, in your company, there'll be developers, right? You can use whatever language or platform that you like. Okay. But the point here is that when you write your application, you have to sort of include in your application the AWS SDK, okay? AWS SDK, Software Development Kit, and the kit is available for all programming platforms, right? So .NET, Java, PHP, Ruby, iOS, Android, right? Whatever platform that you may have, there's a SDK available from AWS, and you have to sort of download and install the SDK on your in your environment, right? And then you have to sort of require or include that SDK in your code. Okay, so the SDK is basically a library, right? And it makes it easy using the SDK. You can basically make the AWS API calls, right? So it makes it very simple to use the AWS services, right? So here, what is happening in this sample code is that first you have basically included or required the SDK library in your application code, right? Next, what we've done is we have created an object called dyn here, dyn, right? And this is an object of the class DynamoDB resource. Okay, the class is called DynamoDB resource. This is a class which is available in the SDK, Software Development Kit. All right. So once you create that object, you also create another object called table, right? And this is from a class table, and you've also specified the music table that we created earlier, right? So now this object refers to the music table that we have in the cloud already. All right. Okay. And then finally, to add an item, right? This is a program that will add an item to your DynamoDB table, right? So we use a method which is part of this class, the table class. The method is called put item, right? So in the put item, you have to basically specify the item details. So you must have the primary key, artist and song title in this case, right? And then you can have any number of other attributes like genre, year, album, and so on. Okay. So this is how you will your application will interact with DynamoDB to add an item. All right. Okay, I'm going to talk about explain the SDK a bit more. All right. Let's just look at the code here, and then I'll explain the SDK a bit more. Okay. So this is one example, right? This is one example. Now let's look at another example. Let's say this is list items. All right, so this is another piece of program that can list your item. So it's basically doing the scan operation, right? We've seen the scan operation earlier. So this piece of program is doing the same thing, essentially listing the items that are available in the table, right? You can add stuff like filters, etc. But here there's no filter, right? So you can see the code here. Same thing, include the SDK. Create an object of the DynamoDB resource class, right? Create an object of the table class referring to the music table that we have, right? And then the output comes from this method called scan, right? and you can add, I mean, right now we don't have any filters, but you can add filters, and the scan basically, will fetch all the items in the table, right? Okay, and then because you're likely to have multiple items in the output, you will loop through each item, right? You can loop through each item, and then you can do some processing. For example, we're just displaying the details. Okay, so this is another sample program, and here what we're doing is we're doing a scan, we're doing a read, right? The previous program was adding items, so it was doing the write, and this one is doing a read using the scan operation. All right, okay, so this is how you write programs. Let me also show you one more, maybe. Okay, so this is a get item, right? This is a query. The previous one was a scan, right? And now this is a query. And the difference here is that we use the get item method, right, or operation. And you have to specify the primary key. Okay, so we specify the artist and the song title. Both have to be specified because it's a composite key, right? So you specify both, and you get the result, right? So, so if there's no result found, you display no result found. Otherwise, you basically display the details of that particular item. All right. Okay. So this is a few. We've seen 2 or 3 sample programs on using the AWS SDK, right? And this is how your applications will be interacting with the DynamoDB table, right? Okay. Now you might be wondering, where do we get more information about the SDK, right? So what you should do is search for the SDK, AWS SDK, and you can see you have SDK for Java, Ruby here, right? Then there's PHP here, and so on. So you'll find SDKs for all major programming languages, right? .NET as well, and let me show you the Ruby page. Right, and so what happens here is this is actually quite similar to the CLI, the command line interface, right? And remember, whatever you do from the console, right? Whatever you do from here, actions like say, adding an item, right, or scanning, right? All the actions that you do from the web console can be done from the CLI, right? It's just another interface. And the same actions can also be performed via the SDK, the software development kit, right? So the web console, the CLI, the SDK, they're all interfaces, right, to the AWS backend, right? The resources are the same, the actions are the same. It's just 3 different ways in which you can use AWS. All right. Okay. So that's what the SDK is. And here, in this case, you can see, first you have to sort of download. Download the SDK, or you can sort of download and install. In the case of Ruby, the command is very simple. You can see it's just a single command, right? Or you can add it to what's called a gem file, where you can install. It's basically a configuration file containing all the gems or modules that you want to install, right? And then you can add that line to the gem file. So basically, the installation is very simple. Right? That's the point here. So if you look at the SDK for Java, you'll find something similar, a very simple way to install the library, right? Once you install the library, then your developers have to sort of learn how to code, right, using this library. So what you can do is you can go into the API reference, right? This is documentation on the SDK, the classes and methods that are available. Okay, so for example, you can see here on the left side the various services, right? So EC2, S3, etc., etc. Let's take a look at DynamoDB here, right? And this is the table class, right? So we have the resource class, we have the table class. Let's take a look at the table class here. And if you scroll down, you'll find the various methods, right? So there's get item, put item, right? There's also scan, right? So you can, maybe say click on one of these methods, and you'll find the full documentation, right? Including an example, right? Including an example. Okay. So your developers have to become familiar with the SDK, right? And especially they should know this API reference. They should start to learn the classes. They should learn the various methods and operations that are available, right? So there's a bit of a learning curve. when it comes to using the SDK for AWS services, right? But once you sort of do that, you can write code in a very simple manner, right? You can see the code here. It's very short, right? It's very small. The amount of code is really very little, right? It's basically this line here. Then there's a object definition, right? And then the use of the method, right? So it's very simple to sort of interface with the AWS resources. All right. Okay. So that's DynamoDB. That's DynamoDB. And let me stop here. Next we'll talk about Elasticache and Redshift. All right. Okay. So yeah, let me know. Right. Let me know any other question on DynamoDB as well. And if you have any questions on RDS, because we looked at RDS yesterday, some of you might have had some time to review RDS, practice RDS, right? So feel free. We'll be using the whole session today, right? So we have quite a bit of time to sort of discuss databases because it's a very important topic. All right. So this question, in your example, where you're connecting to RDS from a Ruby code. No, it's not RDS. It's DynamoDB. Right? So it's not RDS, it's DynamoDB, right? First of all, so it's DynamoDB, right? Not RDS. And the question is, where's the configuration parameters like endpoint, etc. Yeah. So the way this works differently, right? DynamoDB is a very different service. It's you have to the problem is we are used to things like a connect string, and we are used to connecting to traditional databases, right? DynamoDB is not traditional. Okay, so the way this works is you can when you use the SDK, right? When you use the SDK, your app, your code will know how to connect. Okay, it doesn't need any endpoint. There's no endpoint, right? There's no endpoint. The endpoint is defined when you sort of create the object, right? So there's no endpoint here like it is with RDS, right? RDS is more traditional, so there's no endpoint, right? And the way it knows what table to talk to is, you can see here, right? This is the table that you define, right? So as soon as you say music here, the application knows that it has to sort of read or write from this music table, right? Of course, the music table has to be there, otherwise it won't work, right? And also you can see here the region has been specified here as well. So this is enough, right? This information, these two pieces of information, this one here and then this one here, is enough for the code to know how to sort of talk to the DynamoDB table. Okay, there's no endpoint here. Yeah, it is enough, right? It is enough because the region and endpoint is all that you need. What else do you need, right? What else do you need? Of course, table name is unique in a region. Yes, of course, it has to be, right? So it has to be unique. All right. Okay. Now, one more thing that is important. You can't write code and the code won't run straight away. You need permissions. Okay. So permissions is very important, and that we'll talk about in a later module, right? So you can't run this piece of code straight away. In fact, let me try and run one of these programs, right? So if you try to run this program, let's say this one, right? It should fail because there are no permissions, right? So you need to, well, okay, it didn't fail because I guess this has permissions set up, right? But your application, when it runs, it needs to have an IAM user setup, right? So that I'm going to explain later in the IAM module. All right. But at this time, you should know that in addition to specifying the region and the table, you also need to sort of set up the user so that the application has permissions. Okay, so if you have these three things, the user, the permissions, right, and the region and the table name, that's sufficient. That's sufficient for the application to connect. All right, next question. Jagdish, can we migrate from existing SQL DB to DynamoDB with less downtime? With no or less downtime, I guess that's what you're saying. No, you can migrate, but you have to transform, right? See, your SQL DB may have a structure; it may have multiple tables, right, and foreign keys and all that. So you have to see how to do it. You have to sort of denormalize, right? You have to sort of combine data, and then you can do it. So it can be done, right? It can be done, not with, I don't know what you mean by no or less downtime, right? It can be done. It's a migration, right? It's a migration, right? Which can be tricky, which can be complicated, right? But you have to treat it like a normal change, right? You have to do it, practice it, test it, right? And then you have to sort of do it, right? So yeah, but downtime for what, right? Downtime for your application. I mean, there are many ways of doing it, right? There are many ways of doing this, and we can sort of look at the details later, right? But the main thing is, first of all, why do you want to migrate, right? The main question is why, right? What is the migration for? Because remember, SQL databases are very different, right? And there are good reasons, right? I'm not saying there's no reason to migrate, right? But what I want to hear from you is, what's your reason for migration, right? That will help others also. Why do you want to migrate from a SQL database to DynamoDB? Okay, so that's something that you should, we can come back to this, right? If you explain your question. Okay, can you show us how to create a table using the Amazon CLI? Yeah, I mean, look, it's not that hard. You can just look at the AWS CLI, right, and go to the CLI reference. All right, go to the CLI reference, find the DynamoDB API. All right, and here you should find a table, find a command, right? So this is the command, for example, create table, right? So so you can look up the example here. There'll be an example in the documentation. Right, something like this. So it's pretty long. So so I don't want to do it right now because we'll have to troubleshoot and all that. But this is the example here, right? And I don't think you need to specify everything, right? You have to specify the name, of course, right? And you have to specify the primary key, right? So the primary key is very important, right? And yeah, so the same example, right? So you have the song title as the key and the artist as the key, right? So I think the table name and the primary key, those are the key sort of things that you need to specify in the command, right? And optionally, you can specify the capacity units and all those things. Okay, so it's very simple, nothing much here. What you have to do is make sure that that you have the permissions, right? And you need to have an IAM user with appropriate permissions. Okay, Gajendra, I created a DB instance. This is RDS, and you installed MySQL Workbench, but I'm not able to connect. I'm using Windows. Is there any step-by-step at the Edureka website? No, I don't think so. But look, see, this is also, I saw some feedback from one of you yesterday saying that, we want to see things in a Windows client, right? So the issue was that that I'm showing things on a Mac, and that person wanted to see things on a Windows machine. Yeah, but look, these things you should be able to troubleshoot through. All right, let me just, it's usually a matter of expectations, right? Look, this course, is for aspiring solutions architects, right? And the assumption is that you have some IT background and you are technically proficient to some extent, right? And this kind of thing you have to sort of troubleshoot on your own. I can help you to some extent, right? There's no step by step, right? But if you do a Google, right? Google is your friend. So in all these cases, I think the best way is to sort of look at the error and Google for it, right? That's the way to troubleshoot. And actually, it's always good to sort of work your way through these types of problems, right? I'm just trying to give you my opinion on how you should do this. Okay, so a step by step is no good. I don't think it should be like a spoon feeding type of thing at all. Okay, because if it's a step by step, you run through the steps and you don't learn much, right? You succeed in doing it, but you don't learn much. It's good that you have errors, right? And then you can sort of work through it, right? And at that point, when you're struggling with it, you'll sort of understand, right? So I think it's very important that you work through this. And the main issues, what I would look at is look at the security group settings, right? Security group rules. You have to check these, right? One is the security group, right? Is the source IP set correctly? Right? If not, or rather, if you're not sure, set this to unrestricted. Okay, which is 0000. Right? So you can set the source IP to unrestricted and try. This could be one issue, right? Also, are you getting an error message or not, right? What is the error message, if at all, right? If you're getting a message, that's good. You can then Google around this message. Okay, that's another one. Third, there could be a problem with the RDS endpoint, right? Is this a public endpoint, right? Remember, when you're creating the RDS instance, you have to specify whether it's a publicly accessible instance or not, right? So if it's not, then obviously you can't connect to it because the endpoint is not public, right? The internet doesn't know how to go there. Okay, so these are some of the issues. It could also be, is this instance inside a VPC, right? In a private subnet. Okay, so if it's in a private subnet, obviously you can't connect to it straight away. Okay, you have to use a jump. You have to use a jump server. This is a term somebody had used in one of the early modules, right? So you have to use a jump server in the public subnet, right? Or have a VPN connection. All right. So these are some of the things that I can think of that can go wrong, right, when you're trying to connect. Okay. The other things, of course, could be the root password, right? Root username and password. Is this correct? Right. These are some of the things that you would check. And you should, if you really try and troubleshoot, spend a bit of time, I think you'll be able to solve it, right? If not, you can ask support, by the way, right? The other thing you can do is send the details, right? You have to send details like what error message and what you're seeing, what are the steps, right? So things like send the steps, send the error messages, right? All this you should send to support, right? And somebody will help you, or they will get in touch with me if required. Okay, all right. Next question, Rao, could you show us high-level architecture diagram showing how RDS with the web app server sitting in a VPC in a private subnet? What would be the best design for high availability? Yeah. Sure. So this one is a good one. Is a good question. So what I recommend that you do is you go to what is called the architecture center, right? Architecture center. So I'll give you the link to this page. Now, in this page, if you scroll down, somewhere in the middle, you'll find what are called reference architectures. Okay, reference architectures. And the first one here is for a web application hosting, right? And if you look at this reference architecture, you can see here how RDS is being used, right? So you have basically, forget about CloudFront for the moment, right? So you have a load balancer, which we will talk about in the next module, right, tomorrow. So the load balancer, and then there's an auto scaling group of servers, right? So it's just a group of servers which can scale automatically based on the load, right? So you have one group, auto scaling group with a load balancer for web servers, another one for application servers, right? And then behind that you have a RDS instance. This one is the master, right? And then this one is the standby or the slave server, and this has a replication between the two. Okay, so this is the reference architecture, and you can see the subnets, by the way, right? You can well, not the subnet, but you can see the zone. So this zone, this one here is zone A, right, to the left, and the other one is the zone is another zone, zone B, right? So so this is how it is. And now the subnets, right? The subnets, you should what you should do is you'll have the database in the private subnet, right? So you'll have to have two subnets. Okay, so one private subnet in zone A, another private subnet in zone B, right? And the databases will have to be in the private subnet. Okay, the application servers and the load balancer should also be in the private subnet, right? So they can be in the same subnets. Okay, so you have two private subnets, and your application servers and the databases are in the private subnet. Okay, all right. Now the rest of it, the load balancer, especially here, right? The load balancer will be in the public subnet, and the web servers. Web servers also, actually, you can put them in the private subnet. Okay, you can have the web servers in the private subnet, or you can have them in the public subnet. Okay, but the application tier and the database tier definitely should be in the private subnets. Okay, all right. So let me share this link with you. Let me know if you have any further questions, follow-up questions on this. All right. So this is the reference architecture, and this is the architecture center, by the way. Okay, so two links. The second one is the architecture center. It also has, by the way, this architecture center also has a very good, in addition to the reference architectures, it has white papers, right? Architecture white papers, and some of these are very, very good, right? Like this one, the first one, the second one here. Both of these I recommend that you read at some point. Okay. White papers, solutions architect especially, right? You have to read white papers on an ongoing basis, right? So these are very, very good resources. These are written usually by AWS employees, right? Either those who are on the development side or those who are on the solutions architect or consulting side. Okay, so very good sources of information. All right. Okay. Okay. Next question. Can you touch upon migration SQL to NoSQL, enterprise to cloud? Yeah, SQL to NoSQL, you need some transformation, right? Basically, what first of all, you should be very clear why you're doing it, right? Like I asked above as well, right? Why do you want to migrate from SQL to NoSQL? I can understand enterprise to cloud, right? But SQL to NoSQL, why? Okay, because remember, they are totally different technologies, right? And you should have a very good reason. Okay, now some of the reasons could be, right? Some of the reasons could be that you didn't have NoSQL earlier, you have NoSQL now, right? And you have very large scale, and you need fast performance, right? So there could be some cases, right? There could be some use cases where you want to do this kind of migration, right? So maybe your e-commerce catalog was in a SQL DB, right? And now a SQL DB is not good enough, right? Good enough because you are scaling, right? Your data growth, like you're saying here, right? Because data is growing very fast. Okay, so these are good reasons. These are good reasons, right? But you may not be able to able to replace the entire SQL, right? So SQL should remain, right? SQL DB should remain. SQL DB should remain for things like queries, analysis, joins, right? So it doesn't have to be like a full migration, right? Part of it can be migrated to NoSQL, right? So that's point number one. The other thing now is, how do you migrate, right? So how do you migrate? I think you can find resources on this. I've not done this myself, right? But my guess is you'll have to basically do some denormalization, right? Remember, in NoSQL, everything, right? Everything is in a single table, right? You can have multiple tables, right? But let's say if you're talking about the e-commerce catalog, right? Then everything has to be in a single table. So what you need to do is you need to denormalize, right? Normally, when you normalize, you break up, say, an entity into multiple tables, right? And you have the foreign keys for join. So you have to sort of denormalize and merge multiple SQL tables into a single table, right? So this is the main job here, right? Now I'm not sure if there are tools, right? There may be some tools out there which do this. I'm not very familiar with them, right? But this is what I can tell you at this point, right? It's basically a work of sort of merging attributes from multiple tables into a single table. Okay. All right. So and then you can have a script, right, to load. I mean, if it comes to loading, you have some. You can use the API. You can use the SDK to sort of import, right? To import, you can use the SDK, right? The SDK or the CLI. There are some batch operations as well. Okay, so look for the batch operations that you can use to sort of import. There's also another service called data pipeline. Right, there's a AWS data pipeline. It's another service. This may be useful. Okay, this may be useful. So a data pipeline is used for one-time or ongoing uploads into various database destinations, right? And the destination could be DynamoDB as well. Okay, so this is what I have on NoSQL, SQL to NoSQL migration, right? If you have anything more specific, we can discuss it. Okay, let's look at this comment as well, right? One of you has said this. Let's see here. Yeah, so denormalize, then use sync services to write the data into both databases. Yeah, I guess. Okay, so this is useful, right? This comment is useful. So denormalize and then use some kind of sync service to write database, and you basically saying you can compare as well, right? So sort of create your NoSQL database, compare the performance as well, and then see, right? And then if you want to migrate, you're suggesting Splunk or Spark, Spark to stream data into your database. Okay, so I don't know if you need to stream data, right? Because it's a one-time migration, but I think as far as NoSQL is concerned, the tools available are the SDK and the CLI and the data pipeline. Okay, all right. So that's on SQL to NoSQL. On enterprise to cloud. On enterprise to cloud, usually, right? It can be pretty trivial, right? Some DB migrations can be trivial. Okay, you just have to dump, right? So what you have to do is you have to export your DB, right? Transfer the file to the cloud, right? And import. Okay, so that's a regular the way you would move a database from one server to the other, right? So it can be trivial sometimes, but sometimes it can be hard. So for example, if it's a large database, right? A large database can be hard. Okay, so a tricky use case, right? A tricky use case would be say a large database, right, to the time, right? You may not have time. No or low downtime scenario, right? So these can be tricky because you have to sort of get up and running on the cloud very fast, right? So these are some issues that you may face. So here, what you can do is for large databases, some of the tricks are for large database, right? The tricks are turn off binary logging. Okay, because binary logging can consume lots of resources, storage, and compute. So that's one trick. Look at export options, right? You can export in SQL or a file, right? You can export into a file as well. So there are multiple export options. You have to see which one works faster. Okay, which one works faster because you're trying to cut down the time it takes to export and import. Right? So these are some of the things that you can consider. Also, import from the cloud. Right? Your file should be in the cloud, not in your on-premises network. Right? You should first transfer the file, first transfer the file to the cloud, maybe to an EC2 instance, and then import from there. Right? This way, the network latency will be lower. Okay, so these are some of the things. Some people also do for to cut down the time, right? To cut the time, people also do replication. Okay, so what they do is migrate, right? Migrate the DB, the latest copy of the DB, and then turn on replication to sync up the database. Okay, so these are some of the strategies. All right, there's also another point. There's a service called DMS, database migration service, right? So here, what you do is you specify the origin, the destination, and this will do things like replication. It can also do some transformation, by the way, right? So this service you can consider because it can do some transformation, right? It can do transform your data from one type to another, for example, right? Say from Oracle to MySQL, those kinds of things it can do. It can also do replication, right? So this may be something that you want to consider. You can also do it manually, right? I would prefer to do it manually because you have full control over the process, but you can consider database migration service. All right. Okay. Can you take different use cases? Show us migration policy. No, so it should be more specific, right? This is a big topic, right? As you can see, and we need a lot of time. So if you're more specific, maybe we can talk about what you are facing, right? As part of your projects, you might be working on something. So it'll be very good for the rest of the group as well to have like a specific use case, right? And then we can discuss it at length, maybe in some other module, right? So we have module 10, right? Module 10 is where we have an open session, right? So we'll find time for these kinds of questions there, right? And like I said, it's better if you have a specific use case, right? That is better. All right. Okay. Next question here. Yeah, Chandra. So, what is DMS? Is it only for traditional to RDS, or deals with other deals with NoSQL as well? No, it's only RDS, I think, right? So last I checked, although they keep changing, by the way, right? They keep changing things. So last time I checked, it was only for a relational database. So this one here, right? This one here, and okay, so it looks yeah. So looks like they have added this, right? So it looks like they have added support for S3. S3 can be a target. MongoDB and DynamoDB can be a target. So it looks like they have added all these things, right? And as far as the source is concerned, they have Oracle, Teradata, and other types of products, right? Warehouse type of products as well. Okay, I think you can also migrate to Redshift. It's not mentioned here in what's new, right? But you can also migrate into Redshift in addition to migrating into RDS. So RDS, Redshift, and DynamoDB, right? And MongoDB, if you're running it on an EC2 instance, right? All those things are, looks like it is covered. Okay, so yeah, so yes, so RDS, Redshift, and DynamoDB, right? Also MongoDB, but remember this is on EC2, not on any other service, right? And also it is S3. S3, you know, you can, some people are thinking of S3 as a source of as a some kind of a database, right? So there are some analytical tools where your data can be on S3, right? It's not a database, it's just a storage service, and the analytics tool can take data from S3 and display the analysis. Okay, so these are all targets, right? The targets supported are all of these. Okay. Okay. Next question, Sashi. As per discussion, NoSQL used for rendering purpose, and when transaction, we have to go with RDS. So for a single application, we can use two different database technologies. Is this the right solution? Yeah. No. So you know, it's not about rendering versus transaction, by the way. Okay. So it's not. I would not say rendering, right? I'm not going to say rendering, right? Transactions also, DynamoDB is fine. Okay, DynamoDB is okay, but yeah, look, the main difference is NoSQL is large databases, right? Very large DBs, also faster queries, okay, and a flexible DB structure. Right, so this is the main difference. Okay, whereas SQL is good for queries, right? Queries and joins. You know, when you have joins and you want to do some complex queries and analysis. So for those kinds of things, SQL is good. Okay, so it's not about transactions. You know, it's not about transactions or rendering. Both can be done on both. These are the main differences that are defined here. All right. Okay, now to the other part of your question, for a single application, can we use two different database technologies? This is the right solution. The answer is absolutely yes. Okay, that's what the main message of this module is. In one stack, one app, use both RDS and DynamoDB, right? Or whatever, or Mongo, right? This is normal. And this is what is good about the cloud, right? Before the cloud, you know, to run even a single database used to be complicated, right? You had to take care of scaling, patches, replication, failover, etc. Right? But on the cloud, it's much simpler. So you can actually start using different database technologies in your single application as well. Right? So it depends on the part of your application. For certain parts of the application, DynamoDB will be better. For certain other parts of the application, RDS will be better. Okay. So you know, for example, in this case, right, let's say this is your application. Then this, when I click on this link, this should come from DynamoDB, right? Whereas you know, there could be say orders, right? If I click on my orders page, that data will probably come from a traditional database, right? So in a single application, both or more, even others can be. You know, we'll talk about Elasticache, for example, right? So even that can be included. So you have not just one, not just two, you have three, right? So yes, definitely you can use both in a single application. Okay, and this is you know, what you have to do as a solutions architect, right? So in the cloud, it is now possible to use multiple DB technologies. Okay, and this you will do when you're creating a new application, right? But also migration, right? Legacy applications. What you should do is migrate as is, right? After migration, you can decompose your database, right? This will normally be a large database, let's say Oracle or something like that. So decompose your database into RDS, DynamoDB, Elasticache, right? So you can break it down later. After migration, you can think about improving your application. And one of the things that you can do this is called optimization phase, right? In the optimization phase, after migration, you can decompose your database into multiple pieces so that each part of your database works with the best technology there is for that type of data. Okay, so yes, definitely. All right. Okay. Next question. All right. Okay, so this is a response, I think, to one of the earlier questions on migrating, right, from MySQL to from MySQL to NoSQL. Okay. Um, yeah. Okay, so it's just a comment. It's some information shared about migration, right? So you guys can go through this and maybe you can discuss as well how to do something like this. All right. You'll also find lots of other resources on the web, I'm sure. All right, folks. So okay, so now this is a DynamoDB, right? This is DynamoDB. Let's talk about the other two. So we have about 1 hour, and I think that's enough to complete the other two services. So let's now talk about. Okay, let's do Elasticache first. All right, Elasticache, right? So this is an in-memory cache. All right, in-memory cache, which means the data is stored in the RAM, right? Not on disk. It's in the RAM. But otherwise, it's a database, right? It is a database. You can have key-value pairs. Sometimes you can have more complex data structures as well, and all that data is in the RAM, in the memory, so it can be retrieved much faster than it could be if it were to be in a regular database. All right. Okay. Now this you can see this slide. The way all this works, right? Let's look at the picture on the left side here, right? So the way your application has to be written is that let's say there's a certain piece of information, right, that has to be in a cache. Normally, what you should store in a cache is stuff that is frequently accessed, right, and accessed by a large number of people. Okay, so frequently accessed data accessed by a large number of people. So that kind of data will go into the cache. Okay, you'll have to store it in the cache, right? And that same piece of data will also be in your regular database, right, which could be RDS or it could be NoSQL. Okay, so you have your regular database and you have the Elasticache or a cache server, right? And your application, the way it works is when it needs to fetch that piece of information, it should first look in the cache, right? First, it has to look in the cache. So it'll go to the cache and ask for that piece of information, right? Maybe using a key, it'll ask for the value of that key, right? So if it finds the value in the cache, that's very good, right? That's very good because you get it really fast and you can use it in your application to the further processing, right? Now, if you don't find the information in the cache, then what you can do is you can go to your regular database, right? Fetch the value, right? Fetch the value, and at that time store it in the cache, right? At that time store it in the cache so that the next time you have it available in the cache. Okay, so this is the normal way of using a cache server. Okay, so cache server has to be used along with a regular database, and your application code has to change a bit, right? Not too much, just a bit, and all it has to do is first look for the value in the cache. If you find it good, if not, go and fetch it from the main database and write it into the cache. Okay, this is how your code has to be written. All right. Now the Elasticache as a service, it supports two cache technologies, right? One is called Redis, the other is called Memcached. Both are open source. Okay, both are open source technologies. All right, and so this is in that sense, Elasticache is very similar to RDS, right? Remember, RDS supports the major database technologies: Oracle, SQL Server, MySQL, MariaDB, and so on, right? So in the same way, Elasticache supports two of the more popular in-memory cache databases, right? So this is Redis and Memcached. Okay, so between these three, I hope you are seeing that DynamoDB is the odd man out, right? DynamoDB is odd because A, there are no servers, right? B, it is a proprietary AWS technology, right? Whereas in RDS and Elasticache, AWS is supporting the standard technologies, right? The open technologies, the commercial products as well, right? Which are already popular. Okay, so DynamoDB is the odd man out. It's a little different in its architecture and the nature of the technology as well. Okay, so this is Elasticache. Now, when do you use a cache? There are many use cases, right? But the general rule is if anything is frequently accessed and if it is accessed by a lot of people, right? If a lot of people access something frequently, that's even better. That's definitely a case for storing that in the in-memory cache. Okay, so for example, right, let's just take one example. You can read through this list, but let's say leaderboard, right? In a game, the leaderboard is the sort of the ranking, right? It's the ranking of where the various players are. This could be a very large online game, right? Maybe there are thousands of players, and the leaderboard tells you where you are in the overall ranking, right? And the leaderboard is something that is leaderboard is something that is seen by all the players, right? You may have 1,000 players, 10,000 players in the game. It's an online game, and the leaderboard is seen by all these players, right? And also the leaderboard is fetched many times, frequently, right? Because you have to keep checking where you stand in the game, right? So this is a very good example of what you should have in your cache. All right, and there are other examples as well. Okay, so anything frequently accessed by a lot of people should go into the cache. All right, now these two database technologies, right, Memcached and Redis, they're both open source. They are not AWS technologies, right? But both are supported, so you have to choose, right? You have to choose. It's like choosing between Oracle and SQL Server in the RDS side, right? So here you have to choose between these two, and normally, you will just go with what you already use, right? So you may, most people work on existing applications, right? And your existing application may be using a cache, right? And you may have already selected one of these, right? So then you can simply go with that technology, right? However, if you're writing a new application and you're considering a choice, right? You're considering what to use between these two, then I would recommend that you go with Redis, okay? Because from what I understand, Redis is a newer technology, okay? It actually, was written by somebody who was created by somebody who was a long-time Memcached user, okay? And so this person had very good knowledge about the strengths and weaknesses of Memcached, and presumably, he wanted to create something better, right? So that's how Redis started. That's the history there. And basically, it has, you can see the features, right? It is better in that Memcached only supports key value pairs, whereas Redis can support more complex data structures. Redis has master slave replication. You can persist some of the data in Redis, right, and so on. So Redis, by and large, I think the consensus in the industry is that Redis is better if you have to select one for a new application. Redis would be the better choice. Okay, so but anyways, I don't want to it's an opinion, right? It's an opinion. You should do your own evaluation, and you can select the one that you prefer. Okay. Now on the hardware side, right, Elasticache is similar to RDS. It uses servers. Okay, it uses servers, and Elasticache is built on top of EC2 instances, right? That's why all this will be familiar to you, right? You have the micro server, the small server, the extra large server. You have memory optimized as well, because here memory optimized is very important because these are in-memory databases, right? So you should definitely consider memory optimized servers for Elasticache. Okay. Otherwise, the size depends on your particular needs. All right. Okay. So let's take a look. Right. Let's take a look at how we can use Elasticache. Okay. So under the database category, we have Elasticache, right? We have Elasticache, and here let's go ahead and create one. Okay, so I'm just going to show you how to create a cluster, and I'm going to go with Memcached, We could have gone with either, but let's go with memcached for now. And the way you do this is, it's very similar to RDS. You specify, let's say this is your instance identifier, right? So let's say it's a memcache server, right? You should change the node type. Okay, the default node type is large, right? So you should, when you're practicing, make sure that you change this. Don't forget, because it's a very large server, right? The cost may be too high. So just make sure that you choose micro, right? So this is one important change. All right. You can also have multiple nodes. Normally the cache memcached cluster will have multiple nodes, right? For test purposes, we'll leave it at one, but you can change the size of your cluster. All right. And one very important thing is that the memcache, or rather the Elasticache cluster, can only be accessed from EC2 instances. Okay, you can't access it from, say, your on-premises server, right? So it can only be accessed from EC2 instances, and the EC2 instance and the cluster should be in the same VPC. Okay, should be in the same VPC. So you can use the default VPC, right? This is my default VPC. Let's use this. Make sure your cluster comes up in this, and also your EC2 instance that you use to connect to the cluster also is in the same VPC. All right. So this is a very important step. Don't forget that the EC2 instance and the cluster should be in the same VPC. All right. Okay. So this is how you create a memcached cluster. And let me cancel this because I've already created a cluster. Okay. This is my cluster, which is already there. And now we need to connect to it. Right. I'm going to show you how to connect to the cluster using telnet. Right. And then I'm going to run a few commands just to give you some familiarity with how to use a cache cluster. Right. But normally you'd have to sort of use the memcached commands in your application, right? But today we'll just see how to connect via telnet and run some commands. Okay, so I need an EC2 instance. I can't connect to this cluster from my computer. Okay, the way we have done with RDS, right? I can't do that. So we have to sort of set up an EC2 instance. Let me go ahead and do that. All right, so let's go to EC2 and create a server, right? This is going to be an Ubuntu Linux server as usual. Okay, so this is in the same VPC. It's going to be in the same VPC as the Elasticache cluster. Okay, that's very important. All right, so let's go ahead and create this server. All right, so now we have the server, right? We have the server, so we'll have to SSH into this. Okay, so we'll SSH into this server. Once we do that, from that server, we'll try and connect to the Elasticache cluster. Okay, so let's copy the public IP address. All right, and we use the usual method of connecting to the EC2 instance. All right, so this is our Ubuntu server, right? This is our Ubuntu server. We are now on the server, and here what you can do is you can do a telnet, right? You can do a telnet from this server, and you need to get the endpoint of the cache cluster. All right, so just copy the endpoint like this, and you can paste it. But what you need is you need a gap, you need a space instead of a colon between the endpoint and the port. Okay, so this is how you telnet. All right, now you may see, it's kind of hung here, right? It's like not doing anything, it's not exiting, but that's fine. That's fine. Okay, so you can run some commands here, and the commands are like this. Let's say get a. Okay, so a is a key value, is the key, right? Is a key, and you want the value of this variable, right? So that's why we say get A, and the response is nothing, right? We don't get any value back, which means there's no value stored in the cache, right? This is something that can happen, and your application should handle that. All right. So let's say if you want to set a value, right? So you want to set the value of A, so you can say something like this. All right, so don't worry about this. It's, these are sort of options here, something to do with the expiry of the value, right? The 5 is the length of the value. Okay, so you say set A, right? And let's say the value is hello. Okay, so we are setting the value of the variable A, right? So you can set like this. Okay, now it says stored. All right, now it says stored. Now next time, if you say get A, you'll get the value hello. All right, okay, so you can see how we've used the set command to store a value, and then how we've used the get command to get the value. All right, so these are the basic operations, right? These are the basic operations that you would do with a memcached cluster, right? We're doing this using telnet, but normally your application, right? Your application has to do these operations, right? And the set that I've showed you is very typical, right? You try and get the value from the cache. If you find it, that's great. If you don't find it, right, go to your regular database, right? Go to your regular database, get the value, store it in the cache for the next time. All right, this is a typical operation that you have to do in your application. Okay, all right, so that's it. All right, I forgot how to exit this. Maybe quit. Let's see. Okay, yeah. All right. Okay. So this is how you will use your memcached cluster. Let me stop here. Let's see if you have any questions on Elasticache. Okay. Please remember this operation, right? This is how it works. So on the left side, right, your application should look for the value in the cache. If it finds it, good. Otherwise, you find it in the database and write into the cache, right? So this one is the get operation, and this one is the set operation, right? So these are typical commands that you would use with a cache cluster. All right. Okay. So yeah, any questions on Elasticache, please let me know. In the meantime, let me go ahead, right? We have about 45 minutes, right? So I think that's sufficient for the last topic that we have, which is Redshift, right? So let's take a look at this one. All right, so Redshift is another database option that we have, right? And this is actually a warehouse, a data warehouse type of service, right? And this happens to be at this moment the fastest growing service within AWS, right? So it's very popular, right? Probably because it's cheap, it has pay-as-you-go pricing, and I guess there's a lot of pent-up demand for a solution like this, right? Maybe the market is not happy with the traditional data warehousing type of solutions. Okay, so that's what Redshift is. Now, okay, so a few highlights, right? Highlights of Redshift are that it's a petabyte scale warehouse, right? Which means it's suitable for serious use, right? It's not just for startups and small companies, right? You can you may be a very large multinational company with very serious warehousing needs, right? This is sufficient. This is good enough. This will work for you. Okay, it's a large scale serious warehousing solution. Okay, all right. You can obviously the warehouses are normally very large, right? What is different about warehouses from normal databases is that the warehouses have lots of data, right? Because the data usually accumulates over time, right? And also the warehouse will have data from multiple applications. Okay, so for example, in my experience in a bank, in a large bank, the bank had literally thousands of applications, right? So some applications in trade finance, some applications in cash management, some applications in collections, core banking applications, bonds, trading, so many different applications, right? And the management would need a view of data across all these applications, right? So you would have to sort of dump data from multiple databases, multiple applications into the data warehouse, right? So that's why warehouses tend to be very large, right? They tend to be very large, both because the data is accumulated over time, and also because data from multiple applications is dumped into the warehouse. Okay, so it's for that kind of use case. All right. Now the special thing about Redshift, right? Because in warehouses you have a very large amount of data, the regular database technologies will not function, right? They are not sufficient because they are optimized for high input output per second, right? They're optimized for transaction processing. Okay. Whereas Redshift or data warehouses are meant for query and analysis type of purposes, right? And you may have a very large number of tables, a very large number of joins in your queries, right? So each query, the execution of a query can take a very long time, will need a lot of resources. Okay, so that's the kind of environment that we are in, right? So this technology has to sort of handle that kind of need, and the way it does it is it uses something called MPP, massively parallel processing. Okay, that's the main thing. That's the main thing about Redshift, and that's how it is different from, say, RDS, right? So it uses MPP, massively parallel processing, and the way it works is you have a cluster. All right, so it's usually a cluster. I think the maximum number of servers is 32 or something like that, right? So you may have a cluster of 2 or cluster of 32. Right, and this cluster is basically servers running the query in parallel, right? That's why it's called massively parallel processing. Okay, it's in a sense, it is like Hadoop, right? Hadoop uses MapReduce algorithms, where Hadoop also processes the query or the script using multiple servers, right? This is different technology, different algorithm, but the idea is similar, right? That you have you process the query in parallel using multiple servers in a cluster. Okay, so in the picture here you can see there's a leader node, right? And then there are compute nodes. So compute node is where the processing happens, and the leader node is like a coordinator, right? This is the one that orchestrates the execution of the query. Okay, this is how it works. Okay, now below the compute nodes, you can see Amazon S3, right? So that is the backup. Okay, it's very similar. This is also running on EC2. Okay, so what AWS has done is first it came out with EC2, and then it's building more and more services on top of EC2, right? So that's the same thing. It's basically EC2 infrastructure configured in a cluster, right, and sort of specialized or optimized for warehousing purposes. Okay, so the backup goes into S3. The compute nodes actually use EBS volumes as well. All right. Okay, so this is the architecture. All right. Now a quick word on pricing. So Redshift is not covered under the free tier. Okay, the 1 year free tier that you have, it's Redshift is not part of that, but they do have a 2-month free trial. Okay, this was recently announced, I think. So a 2-month free trial from the date you start using Redshift. Okay, so that's available, and that too, for only a certain type of node. Okay, so there's a node called DC1 large. Okay, so you have 2 months free. In 1 month, you can use 750 hours, right? So 750 hours into 2 is what you can what you have covered under this 2-month free trial. All right, so so that's an important point. Please remember, it's not covered in the free tier, the 1 year free tier. All right, okay, folks. So I think that's enough. That's sufficient. So let's take a look at Redshift. Okay, so this is the last service, right? Last service under databases. So let me click here, and I have already created the cluster, okay, because it takes a bit of time for this to come up. So we have a cluster already available, but let me show you the launch, the steps involved as well. Okay, so all these things are similar, right? The way we did RDS, the way we did Elasticache, it's something similar. So let's say this is your cluster. You can give this a name, right? Then a root user. Okay, so let's say something like this. All right, and then you can choose your server type, node type. Okay, so it's a small selection available here. Large is the smallest server, by the way. There's no micro, small, etc. Because it's expected that you'll need something as large as this at the minimum, right? So you can start with the DC1 large. This is the one node type which is covered under the 2-month free trial. All right. Okay. So, okay, just give me a second, please. I think one of you has an audio issue. All right. Okay. Okay. So let's continue. So the node type, you can select, but this is the one that is available in the free trial, right? And you can see large. There's ATEX large, right? There's also different types. So this DC1 and DS, right? DS ones have different EBS volumes. Okay, DC1 has SSD volume types, EBS volumes, right? And DS has HDD type. Okay, HDD type. So that selection depends on the kind of data you have. Okay, for large records, if your data size, the amount of data you're reading or writing, if that's large, then you should choose DS, right? Otherwise, you should choose DC. Okay, DC is SSD and DS is HDD EBS volume type. Okay, that's the difference. Otherwise, the size you will understand. It's basically how many CPUs you have and how much of memory you have in the server. Okay, so you can choose your node type. All right. By the way, this one, the large node, has 2 CPUs and 15 GB of RAM, which is pretty good, right? Pretty big. All right. Now you also have to use multiple nodes, right? You have to use multiple nodes. So maybe you can have 2 nodes in the cluster, or you can have 4 nodes, something like that. Okay. You don't have to include the leader node. All right. The leader node is added automatically, free of cost. Okay. It's added automatically, free of cost. You don't have to do anything. Just look at the compute nodes you need. Okay. Don't include the leader nodes. All right. Okay. So that's about it. Let me just make it one node here for demo purposes. All right. And otherwise, you can just stick to the default settings here, right? Just stick to the default settings. No change required. Okay, no change required here, and you can click on continue, and your cluster will be created. Okay, so I'm going to cancel this because I already have the cluster created. Okay, so we have this is our Redshift cluster, and it's in an available state. All right. Okay, now this has an endpoint. This has an endpoint very similar to the Elasticache endpoint or the RDS endpoint, right? And remember, DynamoDB is the odd man out. It is a very different kind of service. There's no endpoint there, right? One of you had asked, where's the DynamoDB endpoint? And the answer is there's no endpoint there because you have to use the SDK, right? And the SDK knows how to talk to the backend, right? But here there is an endpoint, right? And you have to sort of connect to this. Okay. All right. Now, how do we connect to this? So what you have to know is Redshift is actually based on an older version of PostgreSQL. Okay. So this actually, there was a company called Par Excel or something like that. Let me just try and find that. So yeah. Okay. So this was the company which created this technology, and then AWS, Amazon acquired this company. Okay, so this was the company, and this company had used an older version. You know, they had forked PostgreSQL, and then they had built in this massively parallel processing on top of that. Okay, so why I'm trying to tell you this is, you know, when it comes to connecting to the Redshift cluster, right? We need to know that this is basically PostgreSQL technology, right? And therefore, we need a PostgreSQL client to connect to this. Okay, all right. So we need the PostgreSQL client. Now, if you look at the AWS documentation, they recommend uh, Workbench, SQL Workbench. Okay, they recommend SQL Workbench. So you can basically sort of it's a free software, right? SQL Workbench is a free software. You can sort of install this. All right, so you can see here, install SQL Workbench. There's a step-by-step guide as well. Okay, and you can also take a look at the SQL Workbench website to see how to download and some documentation as well. All right, okay. Now here also it says SQL Workbench is not related to MySQL Workbench, right, which we discussed yesterday. One of you said, you know, how do we connect to RDS from Windows? So you can use MySQL Workbench for that, right? But this one is different. It's nothing to do with MySQL Workbench, right? It's a separate software. It's an open source software. You can sort of download this and install it. Okay, but the you know, the installation process is a little bit tricky. Okay, so today what I'm going to do is I'm going to show you something simpler. All right, and what we'll do is we'll simply connect to this cluster using a PostgreSQL client, right? So we'll not use SQL Workbench. We'll connect using a PostgreSQL client. All right. Okay. Let me show you how to do that. So I'm going to use the same server, right? On my computer, I don't have PostgreSQL, so I'm going to use this EC2 instance which we created previously, right? And from this instance, I'm going to try and connect to this cluster. All right. So let's connect to the EC2 instance first, right? So this is going to be our EC2 instance. All right, so this is our EC2 instance, right? And here we need a PostgreSQL client, something like this. All right, so this is not available currently, right? So we need to install this. So I'm going to use our package manager, right? apt get. First, we'll do an update. All right, and then I'm going to do an install of this software, right? I hope I've got the package right. So it's going to be, yeah. So this is fine. This is the package, right, which we need to be able to connect to the Redshift cluster, right? So I'm going to install this package. All right. So once this is done, it's done now, right? So now we have PostgreSQL client here, right? So now we can sort of run a command, something like this. Let me look this up. I don't remember this fully. So okay, so let me just yeah, this is the sort of way in which you write this command, right? So we say psql -h, okay, then the endpoint. So the endpoint is this one. All right, this is the endpoint. All right, and then the port has a small p in this one. Okay, with MySQL you have capital P for the port, but in PostgreSQL you have a small p for the port. All right, and then you have I think the database name -d. All right, and then you have a minus U, which is the minus capital U, which is the root user for the Redshift cluster. All right, this is how you write the command. It is similar to the MySQL command, right, to some extent, but with important differences. So let's try this. All right. Okay, so that's it, right? Now we have connected from the EC2 instance, we have connected to the Redshift cluster, right? And this prompt that you see here is actually a PostgreSQL or a Redshift prompt. Okay, now you can run your commands here. So for example, you can look at the tutorial that AWS has. Right? AWS has a getting started tutorial. So so in this tutorial, you can look at, say, this step here, loading some sample data, right? So here, what happens is you have to sort of create some tables, and then you can load some sample data which AWS has provided. Okay, so let me run a few commands here. I won't show you the whole thing, but let's run a few commands. For example, this one here, create a table called users, right? Just copy and paste, and that's done. Okay, create table is done. Maybe another one. Table venue. So you can basically run your commands like this. Okay, and then you have to sort of load some data, right? And for loading data, there's a command called copy. Okay, there's a command called copy. And what's happening is, at this point, this command is not working, all right? Because it looks like in the US East region, something has gone wrong with the sample file on S3. Okay, it looks like a problem from the AWS side. Okay, but so I can't show you this now. But what you have to understand is, please note that the copy command is a very useful command, right? And this is the command that you can use to load data which may be in a text file, right? A CSV type of file somewhere, in this case on S3, right? You can then copy it from S3 and load it into this table, users table. Right, you need to have some permissions, which we will discuss later, but the copy command is the one that you can use to import data into your Redshift tables. Okay, all right, so this is how you do it, and then you can simply exit, right? You say /q, exit to the EC2 instance, and from there you can exit out, disconnect from the SSH session, and then you're back to your own computer. All right. Okay. So this is Redshift. Now, now we have completed this. Now we have completed this databases module, right? So we have looked at 4 database technologies, right? RDS, which is for relational databases; DynamoDB, which is for NoSQL, right? You don't have to use DynamoDB. You can use MongoDB or Cassandra, right, on EC2. Okay. Redshift is a data warehouse, petabyte scale data warehousing technology, and Elasticache is an in-memory cache. It's a database, but in memory, right? And you have to combine Elasticache with RDS or DynamoDB. All right. So we have looked at these 4, and like we discussed earlier, one of you asked this question, right? Can we use multiple database technologies? And the answer is yes, absolutely. Right? In fact, you should be thinking along those lines. In your application, you may have different types of data, different types of needs, right? So depending on the need, you should choose the right database technology for that part of your application. Okay, and even for legacy applications, you have to migrate them. Normally, the recommendation is to migrate as is, right? Migrate as is. Don't try to complicate the migration. But once you're migrated, you have to then sort of optimize, right? You can improve your application. And one of the things you can do as part of your optimization phase is to decompose your database, right? You may have a single database, maybe an Oracle database. You can decompose it into multiple databases using these 4 technologies that we have. All right, okay. So let me also, in response to one of the previous questions on migration, right? Let me also share with you one migration white paper. Okay, so yeah, so here, this one here, right? So this one here, it talks about, it's a very good white paper. It's a little bit old, okay, but you can see it recommends migration in 6 phases, right? And the last, you migrate as is normally, right? And then in phases 5 and 6, you can optimize, right? And one of the things you do in the optimization phase is to decompose your database. Okay, so this white paper, you can look it up. It's a very good read. All right, so you can look this one up for this question. All right, okay. So now let's do some Q&A, right? Let's do some Q&A and then finish up this module. All right, where did we configure Elasticache for EC2? Where did we configure Elasticache for EC2? No, I'm not sure what you mean, right? The way this is done is, both have to be in the same VPC, right? Both Elasticache cluster and the EC2 instance or instances, right? Because you can access the cache cluster from multiple instances. So both have to be in the same VPC. That's all you need to do, right? And when you connect from your EC2 instance, okay, from your EC2 instance, you can use the Elasticache endpoint to connect. Okay, so that's how we did it. Let me know. I mean, I'm not sure what the question was. So if you can just rephrase, we can come back to it. All right. Okay. Next question. What's the difference between Redshift and BigQuery? So let's see. I'm not very familiar with BigQuery. Yeah, sounds the same, right? So sounds the same. So I mean, there could be differences in the API. There could be differences in the technology, but looks like the same use case. All right, but looks like the technology is different. It's not a RESTful API, right? That's how you. It's it's okay. So complementary with MapReduce. So it is not MapReduce, right? So it looks similar, but the implementation is different, right? This has RESTful API, whereas with Redshift we have to use a PostgreSQL type of client. Okay, so I think it's similar. Right, it's a similar function. It appears. All right. Okay. Okay, so this question here, right? So how can we use Elasticache with other Amazon products for getting fast results? Yeah. No, so that's that's what I showed you. So here, let me go and find that slide again, right? So okay. So this one here, right? So if you look at the image on the left side, all right, the way you have to use Elasticache is that you have to have a regular database first of all, right? This could be RDS, or it could be a database on EC2. It could be MongoDB on EC2, right? So it could be anything. It could be a DynamoDB as well. So you have a regular database, all right? That's one. Second, you have an Elasticache cluster, okay, all right? And then your applications are running on EC2 instances, right? You can also have some application on Lambda, for example, right? So So on some compute service, your application has to be running. All right, that's how you'll set it up. So you have a database server, you have a cache server or cluster, and you have your application on some compute service, which could be EC2, it could be Lambda, it could be Elastic Beanstalk, etc. All right, okay, and then the code has to do basically, a few things. One, it looks up the value from the cache, right? If it finds it, that's great. If it does not find it, it goes to the database, gets the value, and writes it into the cache, right? Remember from the telnet session, I showed you get, right? I did a get from the cache, I did a set into the cache, right? So that get and set type of operations is what your application will do, right? When it has to interact with the cache cluster. Okay, this is how it works. So basically, the way it works is your app runs on a compute service. Okay, it runs on a compute service, which could be EC2 or Lambda or Elastic Beanstalk, which we will talk about later. Okay, Beanstalk we'll talk about later, Lambda as well. But your application is running somewhere, right? And then your application, your app has to work with Elasticache, with an Elasticache cluster, right? And a database service like RDS. All right, and the app basically performs the following functions, right? One is get, let's say A, right, which is a key. Okay, this is a key, and if found, process further, right? If found, process further. If not found, fetch from DB, and write into cache, for the next time, right? This is broadly how the whole thing works. All right, let me just copy this question here. Okay, so this is how the cache cluster works. All right, in your code, you should know the memcached. Memcached will have its own commands and so on, right? So you need to know how to use those memcached commands, or if you're using Redis may have its own way of doing things. So those things you have to learn, right? That's nothing to do with AWS. That's specific to those technologies, right? But broadly, this is how the whole thing works. All right, okay. Next question here. Please explain RESTful API. No, that's just like a web service, right? So you have a web-based API, right? RESTful. So RESTful is it's not a protocol; it's a standard. Okay, it's not even a. I would say it's a way of doing things, right? It's kind of a standard, and you basically can call an API over HTTP, right? So you can call it over HTTP using the HTTP requests methods like get or put or post. Okay, so it's basically web APIs, right? They're web APIs, right? And all right, and you can use JSON and XML to exchange the data, right? And there are other sort of practices and standards. It's not a standard, right? But there are practices and best practices that are used. But broadly, it's just a web-based API. Okay, so you can read about this. Let me. All right, I think the Wikipedia page will be good, right? So it's basically an unofficial standard, right? That's what they call it. And basically what you do is you can it's a web API call, right, over HTTP using HTTP methods like get, put, and post. Okay, data exchange happens over using XML or JSON. All right, XML, you know XML, right? XML is basically tags, etc. Right? So it's structured data, and JSON is also structured data, but it has a different format. Okay, both of these are text based formats. All right, so it's like a web-based API. All right, which is important, right? Because remember, when you normally talk to a database, you use something like ODBC, JDBC, right? But here you have a web-based API. Okay, in that sense, a BigQuery is similar to DynamoDB, right? BigQuery seems to be similar to DynamoDB in that sense, because even with DynamoDB, you saw, right, when we run this DynamoDB Ruby program, it actually makes a call over HTTP. Right? So BigQuery seems to be something similar. All right. Okay, folks. Any other question? Please let me know on databases. Right? We are done with this module, but we had to take more time. Right? We had to take more time, so we have less time for the next module, right, which we will do tomorrow. So let me just explain tomorrow's module, because it's very important, right? Let me just explain this, what's coming up tomorrow, so that you can maybe prepare a bit for this. Okay, so what we're going to do tomorrow is we'll look at high availability, scalability, and fault tolerance. All right. So these three things, high availability, scalability, and fault tolerance, is one of the main jobs, right, of a solutions architect. Okay, why? Because nowadays people have become used to Facebook and Gmail and things like that, right? And these guys, Facebook, Google, have done such a great job. You probably don't remember when Facebook was down last, right? And it's always fast as well. So they've done a very good job with infrastructure, and everybody is now used to this level of service, right? And therefore, it's very important that your applications are always up, right? They always perform well, right? These have become hygiene factors, right? So in a competitive market, if your product is down, right, your reputation will suffer, right? And even if you're not in a competitive market, let's say it's an internal application, right, in your company. Your employees of your company have the same expectations, right? They will ask the same questions. Why can't our applications be as good as Facebook? Okay, so it's become a very basic thing, a hygiene factor. All applications have to be highly available and really fast, right? And that's why these things are important. Okay, so fortunately in AWS, it's very easy. Okay, it's very easy to create a highly available, fault tolerant, and scalable application. Right, we're mainly talking about mobile web applications or mobile backends, right? Those kinds of things. So it's very easy to do that, and the way we do it is using load balancers and auto scaling, right? So these are not separate services; they are part of EC2. Okay, they're part of the EC2 service. So that's what we'll be looking at tomorrow. We'll see how to create a load balancer, how to make it work with EC2 instances. Right, then we'll see how to create an auto scaling group. Auto scaling group is a set of instances, right, which can be scaled very easily, manually, automatically, right? So all those things are possible. So it's very easy to create a highly available stack using these features, right? These capabilities. Okay, so you might want to read up on these things. They are very, very important. Okay. Okay, now the other thing is, once we finish this module, right, you can start working on your course project. Okay, so in the learning management system, right at the end of your course, right, you'll find a course project link. Okay, so you can look at that document. It basically talks about the project. This is a project that you have to complete as part of this course, right? It's a hands-on project, and you can start working on it, because everything that you need for that project will be completed by tomorrow. Okay, so we'll complete all that by tomorrow. You'll have all the information required to start working on the project. Okay, the project is basically setting up an application, right, using auto scaling, load balancers, RDS, and setting all this up in a VPC. Okay, so it's a very good hands-on project, because you get to use EC2, you get to use RDS, load balancers, auto scaling groups. You also get to use VPCs, right, in a hands-on fashion. Okay, so you can start on that, and then if you get stuck, you can use support. right? Please contact support if you're facing any problem, and we'll try and help you out. All right. Okay. So that's what is coming up tomorrow. All right. All right, folks. So I think, if there are no further questions, we'll end early today, right? We don't have enough time to start off the next module. Okay, so we'll do that. We'll do that tomorrow, and today let's end a bit early. All right. Okay. So thanks for joining. I'll see you tomorrow at the usual time.